In the massively successful Fallout game series, nuclear energy can be used to power everything from cars to robot assistants. While here in the real world, nuclear-powered cars are still firmly planted in science fiction, with a big push from NASA, DARPA, and, interestingly, the US Space Force, nuclear-powered spaceflight could be right around the corner. Give that like button a tap, and come with us as we blast off through the door to the universe. Traditionally, space travel has been achieved using chemical rockets. There are two primary systems used for chemical propulsion, but generally speaking, both use chemical combustion to create a predictable amount of thrust. Or, in even simpler terms, fuel plus fire equals flight. However, in recent years, some concerns have been raised about this method, especially considering the increased frequency of test flights and space programs in the last decade. Notable concerns over pollution and payload capacity are at the top of everyone's list when it comes to the problems with contemporary rockets. Burning fuel has a big impact on the environment. Carbon pollution, the leading pollutant produced by burning chemical fuels, is also the leading cause of man-made climate change today. When we consider the payload capacity, chemical propulsion has been plateaued at its peak potential for many years now. The rockets are more than capable of doing what is required of them, but pushing them further and pushing them deeper into space will become a logistical challenge very quickly. And since companies like SpaceX are intent on reaching Mars in the near future, alternative fuels are a must-have for both of these reasons. Minimizing the environmental impact and ensuring these spacecraft can make it there and back again are top priority in the field of rocketry. Historically, this problem has cropped up before. There was a time not that long ago when coal-burning power plants serviced a large portion of the United States. Coal was a reliable source of fuel for decades, but as we learned more about the effects burning coal has on the environment, alternative sources were researched. One of the more reliable alternatives was nuclear fission. A nuclear fission reactor generates a tremendous amount of heat, which is then used to produce steam and spin the turbine. The turbine, in turn, is connected to the electrical generator, and hey presto, you've got power. Nuclear power produces far less pollution, and the power produced is incredible, which means that both the primary concerns about coal were put to rest. Today, nearly 20% of all power plants in the country are powered by nuclear energy. So when NASA and their peers started looking into alternative rocket fuels, one of the first ideas brought to the table was nuclear power. As with chemical rockets, the proposed nuclear rockets also come in two primary flavors. The first is nuclear thermal propulsion. The heat from the nuclear reactor is used to turn a liquid propellant into a gas, and that gas is then funneled into a nozzle to push the craft forward. According to their testing data, nuclear thermal propulsion generates twice as much high thrust as chemical rockets. The other method of nuclear propulsion is the nuclear electric method. Instead of using the heat from the reactor directly to create gaseous power, the heat is used to power an electromagnet, which then ionizes a gaseous propellant, which is then funneled through the thrust nozzles. This method has the added benefit of also creating electricity that the spacecraft can then use to power its instruments, communication systems, and electronics. Public research into these methods began in 2016, and in 2023, NASA and DARPA announced they had chosen industry partners to build their nuclear thermal rockets, with planned testing programs to begin in 2027. When it comes to space exploration, NASA and DARPA have been part of the conversation basically from the beginning. A new player has joined the campaign in recent years, however, the United States Space Force. In an effort to marry traditional chemical rockets with the new nuclear propulsion systems, Space Force has funded a research project into the design, which is being spearheaded by the University of Michigan. Set to the tune of $35 million, the project includes 8 universities, 14 industry partners, and a host of national advisors, making it one of the largest research efforts on the topic in the nation's history. The project intends to mitigate the weaknesses of both systems while maximizing their strengths at the same time. Creating a propulsion system that has a reduced carbon footprint and has better fuel efficiency, but still has the capacity to move quickly when needed, is the ultimate goal. The project states that it wants to maintain the ability of chemical rockets to make swift movements and adjustments for precise spaceflight with a system that also has the fuel efficiency of something like solar-powered electric rockets. This proposed propulsion system will primarily rely upon a nuclear electric rocket for general motion, with smaller chemical rockets in place for quick maneuvers. With this hybrid system, the teams are looking into ways to simplify fuel storage and refueling processes. They are considering fuels that can be used both for the chemical rockets and the gaseous propellant for the nuclear rocket. So far, everything seems to be going rather smoothly, with the singular goal unifying the various departments and teams involved. According to Joshua Carlson, the Space Force program manager for this effort, the Space Force is tasked with securing America's interests in, from, and to space. We're very pleased to work with the University of Michigan and their partners, just like we are for all our other efforts under the United States Space Force University Consortium, as we seek to maintain the Space Force's edge in greater power competition. This marks a return by the U.S. military to direct involvement in research and development of space exploration projects. Largely left to NASA and their peers since the Cold War, Space Force seeks to be directly involved in the next stage of spaceflight, alongside the likes of SpaceX, Blue Origin, and Skyroot Aerospace. While obviously a historic moment in aerospace research, what does this mean on a practical level? Well, if history is any indication, this is huge news. The space race, which was primarily conducted between the United States and the Soviet Union, was largely propelled with the financial backing and manpower of the two nations' respective militaries. In September of 1962, John F. Kennedy gave his speech at Rice University, wherein he informed the American public and the world that the United States intended to land a man on the moon before 1970. Over the next 7 years, the space exploration industry exploded, making leaps and bounds that would have been impossible without the resources provided by the superpowers involved. With the United States government once again getting in the game, the chances of nuclear-powered propulsion becoming the industry norm have gone up significantly. With private industry and federal governments standing side by side, both with the goal of continuing to explore space and understand the universe around us, the stars are now, quite literally, the limit once again. But what do you think? Is nuclear thermal the way to go, or is the nuclear electric chemical hybrid system the right move? Let us know in the comments. This has been Door to the Universe, and we'll see you in the next video.